Hello everybody and welcome back to the Rubber Duck Developer YouTube channel. This is the third video, I think, in the cucumber diseases or BDD and cucumber smells video series. And in this video I'm going to continue investigating different smells that we identified and fixing the next one. So this is about smell 3, which is called the data collector smell. And we're going to discuss it, we're going to see what the problem is, and then I'm going to dive into some Go code where we will fix that in our cucumber diseases practice repository. So once again, there's a quick shout out to the cucumber diseases project that my colleague Roland Germ and I created over the past months, which is a collection of gherkin and BDD patterns, heavily focused at the moment on coding smells and what the problem is, how you get rid of them, in order to teach people like you out there to create better behavior-driven tests, especially using cucumber. If you're not already familiar with what this is, take a look at the first video in this series where I introduce the project and show you where to find everything. The links to the Cucumber Diseases project are in the description. So if you want to go in there and do your own practice with the smells, understand them on your own, maybe in a different programming language such as Java or Python or C#, then you're welcome to do so. And with that preamble said, let's take a look at the next smell in our Cucumber Diseases repository, which is called the data collector smell. So as you can see, once again, where do you find these smells? You just go to cucumber-diseases.github.io, as you can see up here in my address bar. And there you will find an overview on all the cucumber smells that we categorized. And this one is basically the third one, called the data collector. So what is the data collector smell? A data collector occurs if we are using multiple given steps to basically just build a test object or aggregate data in order to, aggregate data on the same object in order to get into a state. Like you can imagine this if you know object-oriented programming languages such as Java, where you can find the builder pattern, which basically is you have an object and you invoke one method after the other to set different data fields. So why is that a problem? Eventually it means that we are constructing our test data or our initial state on the same thing step by step and piece by piece, which leads to very long scenarios or test scripts with individual steps for each of the fields, which is basically just clutter. So what does it mean? So instead of just creating the object in one instance, we build it one after the other. That leads to harder maintenance because whenever the domain object that we're testing, like a user account or the state of a machine that we're testing in a scenario, whenever that business logic changes because we add new fields or remove stuff, we have to go through all of our test cases and test scenarios and reevaluate them, whether they are missing a field, whether we need to add something, whether we need to change something. So we are exposing that complexity to the person creating the test scenarios instead of just hiding it behind an abstract step. So then it automatically increases complexity. That means when I'm consuming the test scenario and when I'm reading up on it, I have to run through the same steps over and over again, just adding mental clutter, because I need to always understand why are we doing these steps instead of just having one thing where I can say, given there's a user with a name and a birth date, I have to run through all that in my mind all the time again. On the programming side, that is also an expression of increased coupling, because I'm going to increase the size here a bit so that you can maybe read it a bit better. Um, so it increases coupling as suddenly our scenarios are much more tightly bound to the steps, and even the order of steps may matter. This is stuff that we could, in a good test setup or in a good test step code, abstract from the scenario creation. But in that case, we may have to keep in mind that changes in one step may tie to changes in other steps. So we may see creating dependencies between steps, which is something that we usually don't want to do because it makes our tests more brittle than they need to be. And eventually, having lots of that will lead to inconsistent data because the user scenarios are now bound to mandatory given steps at some point. So if we would omit one of the steps, let's say we are creating or instantiating a user for our test, and then we would have the steps of given there's a user, given the user has the name of this and that, given the user has a birthday, given the user has this and that email address, shipping address, whatever, and we're constructing that step by step. We may find ourselves introducing mandatory given steps, like every user has to have a name. That's just a business rule. And we omit that, our tests may fail due to inconsistent data because we just lacked giving their information that we needed, or maybe we introduce data to the business logic at a later point that we now need to add to all of the tests. And if we forget that in one step, the test may start to get flaky or may start to fail. So that plays together to increasing the maintenance overhead. And eventually, I mentioned before, and that's just a warning from our point of view, it increases script length. It makes scenarios longer than they have to be, putting a tax on the mental load of understanding them. So if we find something like that in our code, what should we do? And I'm going to show that with an example here. So if we find something like that in the code, this is a typical data collector pattern that we identified in a Gherkin code. You can see we have that given the customer name is Max, and given the last name is Masterman, and when the customer is created, we do something. So this part here is our data collector. And the problem here is we always have to give the user a first and the last name, and we're forgetting that. Then we will have problems in our test logic because that's encoded business logic basically. So if we find something like that in our code, what we should do is we should tie those steps together to create atomic business objects. Like instead of having the first name is this, the last name is that, we should tie that together into just one given statement where we can say, given the customer name is first name, last name. Or if we need more information, given the customer name is first name, last name, and or if we need more information, we could have something like, given there is a customer with a name of first name, last name, and the email address of, right? So what we want to do is we want to get rid of these patterns where we construct an object step by step and pull that together in just one given step that initializes the whole business object. So this is the smell theory around that. In the deliberate exercises, the coding exercises, exercise 003, remove the data collector. And it is rather simple because we know that somewhere in the customer.feature file there is a test scenario, at least one test scenario that has multiple given steps that reflect this data collector pattern, that build up just the same business thing, and then just one when step where we evaluate doing something with that. And what we have to do is we have to identify it and remove the multiple given steps with just one drawn together thing to create a consistent implementation. So let's take a look at the code that's involved here. Okay, so I open up my practice repository project here. This is the Go code project, but the good part for this smell is we don't have to meddle with the test implementation itself. we can fix this smell only by looking at the feature file, because the required step definitions are already there. So what we're looking for in the feature file is steps that include multiple given steps. So we're going through the scenarios one by one to see where we encounter that and to see what we may have to fix. So already the first scenario that we whip up here, that includes the smell, because it tells us there are two steps to create the customer with it, given the customer first name is Max and the customer last name is Masterman. So that is already the smell. So what do we have to do now? There are two steps and we have to pull them together into one. So let's see whether we find a pre-existing step that already does that. Let's go through them. We find that one given there are no customers, and then we find that one here, and the customer name is Rose Smith. Let's make it a bit bigger here. Okay. So we find that one here, and the customer name is Rose Smith. This step does not express the smell because it creates the business object of the customer just in one step with all the data required. So the only thing that we actually have to do is we have to remove those two givens, and we're just going to replace it with one from the next scenario. So we can say given the customer name is Max Musterman. And now if we run go test here, it will take a moment and we should see that everything passes. Okay, with go test being completed, we can see that everything passed and that it ran by using our new unsmelled code. We could scan now for additional parts in the feature file that contain the same pattern, where we use multiple given steps to construct the customer. But I leave that up to you. Maybe you find something, maybe not. So explore the repositories. And with that simple change, we have made the scenario much slimmer, much easier understandable, and to reduce the potential of breaking our test in case we require additional data or we change something in how the object is constructed. That was a short video because that's a short smell to fix. I hope that was valuable to you. If you're interested in going through the cucumber smells yourself, feel free to visit cucumber-diseases.github.io, explore the repositories and try it out on your own, or even contribute to the project by identifying new smells or adding new languages that we're not already supporting. So have a great day and just write good BDD code. It makes your life much easier.